this mic volume. That looks good. Still something else I want to pull up though. So we'll do that real quick. Okay. I don't know how loud this is. So I guess I'm gonna have to test this real quick too, huh? Let's go to here, and we will use this for testing. Blah 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 blah. I think that's getting too loud. It is for me at least. Let's see. Yeah, that's getting a little loud for me. Okay, it's just me then. Right? Yeah, it's just me. So I'll just turn my volume down on my headset, and I will turn up the volume on me. That should be good, yeah? Yeah, that's good. Cool. Let cube xy denote the statement x is the capital of y, for sure. So let's just, truth value of Detroit is the capital of Michigan. Truth value of Detroit is the capital of Michigan is false. I would hope at least. Oh, am I still? Yeah, I think I'm still playing it. Yeah, there we go. This should be good though, yeah? Yeah, I think this is good. Determine the truth value of that. It's false. Next. Oh, I assume that's it. Let n of x be the statement x has visited North Dakota, where the domain consists of the students in your school. Click and drag any of the given English statements and place them next to the quantifications provided. A quantification may be matched to more than one English statement provided. Okay, so here this is going to be some of the students visited North Dakota. Some of your students at your school have visited. All of every student is visited. At least one has not visited. No, that's this one here. This one is saying, let me actually break this down. This one is saying no one. This one is saying no one has visited there. No student at your school has visited. There is a student who has visited. Let's break it down with the nots and yeses. That's a not. That's a not. That's a not. Not. This one has visited. Um. Not. Not. Okay. Some students have not visited North Dakota. Some students not visited. It is not the case that a student at your school has visited North Korea. So, this one. There is a student who has. There is a student. Not all. Has not visited. All of your students have visited North Korea. Each student at your school has not visited North Korea. It is not the case that each student there. Is it not? What? Is it not? It is not the case that each student. That would be like down here, wouldn't it? Not the case that every student at your school has visited North Korea. Yeah, I think that's it. That gets so confusing. Just wording wise, that's so dumb, I think, but. Translate these statements into English, where C of X is a comedian, F of X is funny, and the domain consists of all people. So this is all true, or for everybody. X is a comedian, and that same person is funny, or everyone is funny. Everyone's a comedian, and everyone's funny. Everyone is a comedian and funny. All people are comedian and funny. Yeah. No, that's not it. All people are funny, or not, or every person is a funny comedian. Yeah. Consists of all people. Yeah. And it's the same statements, the same domain. So some people are funny comedians. Some people, some comedians are funny. Not what it's saying. Not all, definitely not all. So there's some comedians are funny, or some funny people are not comedians. So it has to be this one, right? But like, I don't know. That doesn't make a whole lot of sense to me. Like, it's definitely the choice, because there's no knots in this statement. But I mean, I guess I would probably think that would be more EX of C of X and F of X. So this would be outside of this sum. No, I guess not, maybe. Okay, whatever, that's fine then. Click and drag the appropriate word, symbol, or phrase in the most appropriate blank. Let P of X be the statement, X can speak Russian. Let Q of X be the statement, X knows the computer language C++. For sure. For sure. Definitely need more water. Let P. X can speak Russian. X knows language C++. Consider the statement: there's a student at your school who can speak Russian but doesn't know C++. So E of X, EX, Russian, P of X, and not C++. This one. Because of the phrase there is. This statement is that statement because of the phrase there is. So the appropriate quantifier can be applied at the beginning of this one. Appropriate quantifier would be that. We want this symbol to act on X, representing a student at your school. The phrase is student at your school speaks Russian, and a student directly symbolized by that. We know student X speaks Russian, but student X doesn't know C++. Respectively, so that can't be it. It has to start with P. There it is, way over there. Oh, I don't think I'm supposed to be able to. Okay. We know that student X speaks Russian, but student X doesn't know C++. Another phrase, but doesn't can also be interpreted as not. Not a not symbol. Not conjunction or disjunction. The fuck? There's no and. What the fuck? This part's confusing. And doesn't. Okay. That makes sense. Finally, the word and requires the statement to employ the conjunction. Right? Because a conjunction is the and. What is this? Logic. Conjunction and disjunction or negation not. Okay, that's what I thought. Hence, the completed quantified statement is the same thing. Oh. Okay. And that should be... That makes sense, yeah. Yeah, that makes so much more sense now. Okay. Cool. Let Q of X be the statement X plus 1 is greater than X 2X, where the domain consists of all integers to identify the quantifications that have the truth value true. So, just say which one is true. I feel like this can't be that easy, right? Statement where the domain consists of identify the quantifications stations that have the truth value true. Yeah, no, it's legit. Just whatever is true. Cube 0 is true because that would be 1 is greater than 0. Negative 1. 0 is greater than negative 2, which is true. Is it true for everything, though? I don't want to believe so. It can't be, right? It can't be. X is less than... 1 is greater than X. So anytime... So if it's 1, that's false. If it's 2, that's false. Okay, yeah, that's exactly what it is. Okay, so not that one, but some. What is this thing again? Some of not this. There is some that's not this. Yes, because it's not all, so that would be true. And this is also true. And 1 would be false, because 2 is not greater than 2, 2 is equal. There exists an X value where this is false, where this is not true. Yeah, okay. Yeah, that's it. Identify the statements that have the truth value truth if the domain of each variable consists of real numbers. Okay, so the actual statement is changing for every one of these. Yeah, that's definitely not true. So what would this one have to be? X squared is greater than or equal to 1 minus 2, which is just minus 1. X squared is greater than or equal to minus 1. So it can be minus 1. But if it's less than minus 1, so if it's negative 2, that would be false. Right? Is that what it's saying? Minus 2. Which would be 4, 6. It's all real numbers, so that's not true. Because if it's like 1/2, that would be 1/4 plus 2, which would be greater than 1. Yeah, actually, I think that is true. Because there is no way you'd have to get this to be a negative number. And the only way to do that is to use imaginary numbers, and imaginary numbers do not exist in this case. It's only real numbers. So it has to be that one, right? Because since you're always adding 2, that's always going to be, right? Yeah. Because that squared makes it always positive. Okay. That is not true. Well, this actually is true. Because no, it's not true for real numbers. Because that would only be true for I, which is not a real number. This one could be true though, yeah? Yeah. Whatever the square root of 2 is, that's what it's true for. Since it's all real numbers, not just integers. Plus minus square root of 2, so yeah. I want to get some more water, and I gotta take Gatsby outside. So, I shall be back. be right back. me. Fuck. Okay. Express P of X without using quantifiers, instead using only negations, disjunctions. Suppose that domain of the propositional function at P of X consists of -5, -3, -1, 1, 3, 5. Use only negations, disjunctions. Click on the choice or choices that correspond to a correct solution. So there's only one that's true. We can only use disjunctions, so it's only ors. So yeah. There aren't even any negations in this, so that's actually pretty nice. There's probably going to be some in the next one or two, which is probably why it says that. But for this one, it's just either this one's true or this one's... Yeah, it's just one of these are true. Doesn't matter which one, at least one of those is true. So that's good. Success using quantifiers, using negations, and disjunction or conjunctions. So they sound blah blah blah. So all of those has to be true. 1, 3, 5, -5, -3, -1. All ands. Because for the statement to be true, all of these have to be true. Okay. Suppose same domain, express this, all of them. All of these x is not equal to true. If x not equal to true, then p. If then. So to use if then, we have to use negation or and. I think it's negation and. I guess we're not doing that. Okay. That's so weird. It's definitely not this one. Definitely not that one. Definitely not that one. Definitely not that one. I want to say it's definitely not. It can't be that one either. Oh, I guess. When is this? How does this work? If this one's true and this one's false, then the entire thing is false. So if it's not, this one can't be true and this one be false. So it has to be. But if that's not the case, then it could be. It really can be true or false, as long as this one is not true. Right? I feel like I'm fucking this up. Where's my notes at? My backpacks. I never have my backpack here. What the hell? Alright. Now that I have my backpack, I'm going to charge my laptop anyway, since I'm over here. I think I left my laptop charger here even, so I wasn't able to charge it the other day in class. So this is good anyways. Plug that in, let it charge, make sure it is charging, it's charging. Oh. Okay. And I need to find my notes for this class. What color is it? I don't ever remember. It's not green, it's not red, and it is not blue. It is not yellow, so it must be black. Perfect. Okay. The statement for that to be true is the same as saying not P or Q. Okay, yeah. So either P has to be false or Q has to be true. That makes sense. None of those look like that, so that doesn't really matter. But I'm just trying to figure this out. Because I don't think we've ever seen this, so that's kind of confusing. That's like the worst thing about this one right here. This is logical. What is it? Something about logics, digital logic or something like that. Not digital really, but just using truth statements and trying to say what is true, what is false. So for this question specifically, it is just saying that P of X consists of this, so this is the domain, only these X values can be used. And then this is the actual statement. We have all of X is true when X does not equal 1. If X does not equal 1, then P of X. I am a little stuck on this question specifically though, just because I'm confused with the arrow, which just means if this, then P of X. Because I would imagine it would just be, it can equal 1 as long as P of X isn't true. Based off the truth tables that you can create using all of these. Without using corner, click on true. X equal to 1 or P is 1. I feel like this is the case here. Because this would be saying, no, I don't know. X can be equal to 1 or P. 1 is true. If one of these is true, then it's true. I don't think that is the case. We can have X equal to any of these, but it needs to be true for all of them. I'm gonna go with this one. Just a guess, really. I don't really know for this one. Translate in two ways the given statement into logical expressions using predicates, quantifiers, and logical connectives. Let C of X be the propositional function X is in your class, and P of X be X has a cellular phone. X is in your class, and P of X be X, they have a cellular phone. Click and drag the expression into each domain so that the expression subject to the domain has the meaning everyone in your class has a cellular phone. Domain B, the domain consists of all people. What? C is somebody's in my class. P is they have a cellular phone. Click and drag the expression into each domain so that the expression subject to the domain has a meaning. So the subject of the domain has the meaning everyone in your class has a cellular phone. Okay. So for this one, it seems like it is just saying, let's see, what is this one saying? Interesting song. Domain A, the domain consists of the students in your class. So domain consists of C. So C is always true. Everyone, and we want the meaning to be everyone in your class has a cellular phone. I feel like it would be this for all of if they're in my class, then they have a phone. That would be true for this one, because this would be saying that you're getting too loud, too much words. Shut the fuck up. Shut the fuck up. Better? Yeah, I think that's good. Okay. Yeah, the first statement here would just be saying for all of them would be true. If they're in my class, then it's, yeah, because that's always true then. No, that's not always true, because if they don't have a cellular phone, that's not true. So that can't be the case. Right? Oh, I mean, yeah, that one would be true. I think this one would be, oh, it's only one true statement. Because the domain's already everyone in the class, so for all, for everybody, all is true, statement, blah blah blah, I don't know how to word it. Everyone in the class has a cellular phone, that's what that is saying, so that has to be the case. And for this bottom one, domain consists of all people. Some of all people, if they are in the same class, then they have a cell phone. I feel like that's the answer for that, because it's not everyone. For everyone, it's not all people. We're just talking about everyone in the class. So yeah, that has to be the case. That wouldn't be true for everyone. So yeah. Let C be the propositional function. F is in your class. PB. X has seen a foreign movie. Click and drag the expression into each domain so that the expression subject to the domain has the meaning somebody in your class has seen a foreign movie. Okay, so someone has seen a foreign movie. Not everyone. Domain A is all students in the class. Yeah, it's just straight up this. Some people seen it foreign because it's just in the class already. For the domain, some people in the class has seen a foreign movie. That's exactly what that's saying. So at least one person. Domain B is everybody. So there exists some people, somebody. This one would be saying there exists somebody who is in the class and has seen a foreign movie. Yeah. Let P of X be X is perfect. Let F of X be X is your friend. And let the domain be all people. To click and drag the quantifications to their corresponding sentences. What the fuck am I reading? So we're just trying to match what each one of these is saying. What this is, okay. So no one is perfect. So that's P. That just is straight up false then. For everyone, no one is perfect. So AX, P of X. AX, not P of X, that's what it is. There's not a single person who's perfect. Right? Or is it? Yeah, that's just saying not everybody. Okay. So not everybody is your friend. That would be using not everybody, or someone is not perfect. Not everyone is your friend. That's and. So it'll be this one. Not everyone is your friend, or someone is not perfect. Not everyone is perfect. This one is just saying this here. The one that I was confused about at first. So if I just read a little bit more, I would have gotten that. All your friends are perfect. So for all of f of x, p of x. They are perfect and they are friends and perfect. That's not the right one though. We want to use everyone. So this one. Is there going to be multiple answers maybe? Because it looks like we can put multiple ones in there. Everyone is friend and perfect. No, that's not right. This would be more like this one here. For everybody of X, if they're, because if they're not my friend, then it doesn't matter. But if, excuse me. But if they are my friend, then P has to be true. So yeah, I think that's true. That's right. At least one of your friend is perfect. It's just straight up E. What the hell is this? That's not how that works. There exists a friend, somebody who's a friend and they're perfect. Yeah. Everyone is your friend and is perfect. This one here. Everyone's friend and everyone's perfect. That's not the same. That's saying everyone is friend and perfect. I mean, it is, but it's not technically. Maybe there would be multiple answers for this one specifically. Because, like, technically that is also true. Everyone is a friend and everyone is perfect. would be the same as saying everyone is friend and perfect. Yeah. What is this one saying? Not everyone is a friend and everyone is not perfect. Not everyone is a friend and there exists somebody not perfect. So that's not an or. That's just not a right statement. That one is saying there exists someone. There doesn't exist. There's not someone who is perfect. There's not someone who's perfect. So no one is perfect. Technically, that's also true. I don't know if that's going to give me the right answer, but because it's not exactly what it's saying, but that is the same thing. Using the De Morgan's law, that would be, or what is it? Is that De Morgan's law? I think that's the De Morgan's law. Flipping the sign, yeah, yeah. There's not someone who is perfect. No one is perfect. That's the same thing. Yeah, so I think that's all. I don't think we have to use all of them. Click and drag the corresponding sentences. I don't know, because for this one specifically, there is no statement that that's true for. This one maybe. Not everyone is a friend and there exists somebody who's not perfect. Not everyone is a friend. I mean, that's the exact same thing, except it's saying or instead of and it's not. Those aren't the same. Like, those are the same other than the and or, so those can't be equivalent. Because this one's saying either this one is true or this one's true, but this one's saying there's somebody who this is true and this is true for, so that can't be the case. So I feel like that's it. Yeah, I don't know. Consider the set of all proportions. If T of x means that x is tautology and C of x means x is a contradiction. So T of x means they're all true, C of x means they're all false. Express each of the statements using logical operators, predicates, and quantifiers. The disjunction of two contingencies can be a tautology. What? Express each of the statements using logical operators, predicates, and quantifiers. So basically, yeah. The disjunction, so ors, of two contingencies, which is the E and A, can be a tautology. Could be all true. What? This is so confusing, actually. What the fuck? I don't understand what it's asking me to do. Consider all proportions if T means X is tautology. So if it's using T, then they're all true. If it's using C, then they're all false. So T is always true, C is always false. For sum of x and sum of y. I'm assuming we assume that y and x are in the same domain, which would be that y is tautology, y is contradiction for those same things. I assume that. Oh sweet, Filthy Goblins on Overwatch. Can't play though. At least not immediately. I gotta get some of this homework done. And there's almost 60 questions, and I'm not even halfway through yet, so... Yeah, I definitely need to get this homework done first. There exists an x and there exists a y, where not all true and not all false. There exists an x and there exists a y, where I feel like this is just so wrong. For every value. I feel like it just has to be for every value. Because what is the difference between these here? Those are all the same. These 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 are the only ones that's different. The very beginnings here. Junction of two contingencies can be a tautology. So we can either say that the sum of both of them would make it true, all of both of them would make it true, all of x. I feel like because we're given nothing in terms of y, so they have the same domain. But I feel like if they have the same domain, they would be the truth for both of them, both x and y. So it doesn't really matter. It would be one of these. It wouldn't be one of these because they would have to be the same because it has the same domains, right? X or y at the very end. Maybe that's the deciding thing I need to think about. No, because all the other ones has to be true as well then, huh? I feel like it would just be not true. I don't know. This one's so confusing. How does a hint work? Hint 0 is a quantifier existential or universal. I don't... Duh. The fuck? That's not helpful. It's a quantifier existential or universal. That's the question, isn't it? That's what I'm trying to figure out. The disjunction of two contingencies can be a tautology. I would imagine it would be some. But this is just a random guess. I don't know. Yeah, and this is gonna be the exact same issue. Fuck if I know. Because I still have the same mindset that x and y have to be the conjunction of two tautologies is a tautology. The disjunction would be using ors. Conjunction would be using ands. So I don't know. Disjunction of two contingencies. What is a contingency? Can be a tautology. I don't know. I really don't know. Conjunction to tautology is a tautology. Oh, maybe it's what we written down this previous week. Am I supposed to be using the rule of inference? It doesn't say that, but I'm thinking maybe I am supposed to. If that is the case, for this one specifically, I can do that true and that true, then that true. I don't think we are though, because this just gets, I feel like it just gets confusing. I don't know. This is so annoying. I'm pissed. Fuck. Because this is just saying that this is always true, and this is always true, then this is always true, and this is always true. This is always true, and if this and this, then this true statement. So that's just always, I feel like. I don't know, maybe I'm just overthinking it, but consider the following propositions. Let S of x denote x is serious. The domain of all Swedish movies. Express the negation of the proposition. All Swedish movies are serious using quantifiers. Then express the negation in English. What negation? What express the negation of the proposition? Not all Swedish movies are serious. So some Swedish movies are serious. Right? Or is it just all Swedish movies are not serious? I don't know, what does it mean? Express the negation of the proposition. Negation of what exactly? What are we negating? Because we can negate either one. We can negate the all Swedish movies, which would be not all, which is some. Some Swedish movies are serious. Or we can say all Swedish movies are not serious. So it's one of these two. Because these are both true, or these both would be valid negations, if I'm understanding that correctly. Let me look it up. I don't know. Yeah, I feel like it would just be something based on what I'm seeing here. I mean, that's exactly what it says. If it's all, there has to be some, but yeah, I mean, I guess, sure. If that's what negation is, we're just negating the. Yeah, I guess. I can keep a secret. Domain is all people. No one can keep a secret. So there does not exist someone. So not not EX uh SX whatever. That's what that's saying. Or is it not all? Not AX. Not everyone. No, it's just saying no one, not E. Not E, keep a secret. So every not a, there does not exist a person. There exists a person. So I think it has to be this one, yeah. Yeah. Find a counterexample to the given universally quantified statements where the domain consists of all real numbers. Find a counterexample. So find where it is not true. X equals negative square root of 2. Square root of 2 and negative square root of 2 would be the same thing. No, it's not. Because this would be 2. 2 does not equal negative square root of 2, so that's true. That one's true. That one's not true. That one's not true. Yeah, this one's really only true for -1, or not even -1, just 1 and 0. Yeah. Find a counterexample. Domain consists of all real numbers. Okay, so it's different because instead of itself, it's just saying 2. So it can't be the square root of 2. It can't be the negative square root of 2. It can be literally anything else, though. Wait. It has to be those two. Because those two do equal 2. Let me double check the previous one then. All those, yeah, I got that mixed up. Because that would be true. Yeah, that's okay. There we go. I got it better now. Oh, does there exist one for this? For all X values. absolute value of x is greater than 0. Oh, 0. Yeah, that is not true for 0. Yeah. Let's see here. Mm, trying to think. I don't know. Translate the specifications into English where f of p is printer p out of service, b of p is printer p is busy, L of j is printer j, printer job is lost. Q is printer job, print job is queued. It's okay, so just translate it. Okay. For some printers, some printers are out of service and is busy. I was busy translating this. If printer, if some printer is out of service, if a printer is out of service and busy, then if a printer is busy, out of service and busy, then some print job is lost. If there's a printer that is both out of service, then some job has been lost. Yeah. That's it. If all printers are busy, then there is a print job that is queued. Every printer is busy, then there's a print job that is queued. Job that is queued. All jobs are in queue. If there is a job queue, yeah, this is it. Okay. If there's a job, that is queued and lost, if there's a job that is queued and lost, then there's a printer that is out of service. If there's a queue that is both queued and lost, then there's some printer out of service. Wait, what is the difference between these two? Both and either. So this is both. Okay. If all printers are busy and all jobs are lost, or if all printers are busy and all jobs are queued, then there's a job that's lost. Every printer is busy and every job is queued, then some job is lost. Every printer busy, every job queued, then some lost job. Okay. Find the truth values in the statements if the domain consists of all integers. Exclamation point. What does that mean? What the hell? I feel like I don't. What? Oh, okay. No. I was taking the down arrow. That's not a down arrow. That's just an exclamation point. What the hell does that mean? I don't think we've... I don't... What? Maybe there's something on the... what is it called? Something Quizits, what is it? Piazza. Okay, yeah, somebody asked about that. I don't know what exclamation point means in the formula. Question number 25. E exclamation point x, x greater than 1. Is it supposed to represent not or factorial or something? And then instructions answered, it means there exists one and one element. It means there exists one and one element in the domain. Okay. It means there exists one and one element. Only one? Because I don't feel like this was worded great. Because this is what we have here. We have the question. Hey, does anyone know that what this means? Exclamation points. It means there exists one and one element. One and one element. What the hell are you talking about? There exists one, at least one. I'm so confused with that. I'm thinking there exists one and only one element. I feel like that's what he meant to say. Yeah, I'm gonna just see false because I feel like that would be too easy. If that exclamation point wasn't there, that would be true. I feel like that exclamation point is just gonna make it false instantly. So, there exists one and only one value where x squared is equal to 1. I think that's true. Yeah. There exists one and only one value where x plus 3 is equal to 2x. Let's do a bit of algebra, get x by itself, so minus x will be x equal to 3. Yeah, true. Oh yeah, if it's linear, there's always just one value. Duh. Wait, go back, actually go back. -1. That's false. I almost just, yeah, that would have been fun. I would have looked at that again and been pissed. Okay. There exists one and only one value where x is equal to x plus 1. So x is 0, that's false. If x is 1, that's false. If x is 2, that's false. Is that ever true? We can subtract x on both sides, and that would just be 0. That is false, because there is no value where that's true. Yeah, no. Maybe if this was like negative, or the absolute value or something like that. If that was the absolute value, we could say 1/2, but nope. Every x value, there exists a, for every x value, there exists a y value where x is less than y. Yeah, true. For every x value, there exists a y value, so we're looking at x first. For any x we plug in, there's something that is greater than it. Yeah? For every real number x, there exists a single. That's not a single. For every real number x, there exists a real number y such that x is less than y. Exactly. For every real for every real number x and every real number y, if x is greater than or equal to, if x and y are non-negative, then their product is non-negative. Yeah, I feel like that's it. Non-negative, if they are both non-negative. Yeah, no, that's it. Okay. For every x, for every x and y in some z, x and y makes this a real z, so that's true. Yeah, I feel like that's it, right? That has to be it. There exists a real number z such that this is true. That's what that's saying. Okay. Let wxy be this, mean that student X has visited website Y. Domain consists of all students in your school, and the domain Y consists for all websites. There exists a student who has visited this website. That's what that's saying. At least one student has visited that. There exists a student's. Wait, what? I gotta read this now, huh? X, student X, website Y, domain X, all students. Y all websites. And what is Z? What the hell? I guess Z doesn't really matter, does it? There exists a website where every Z based off of this, we're looking at Z is the website and Y is the student. Okay. For every student, or there exists a students. There exists a students. It's not. If there's a student, not David Belcher, and if there exists a student that is not David Belcher and David Belcher has visited every website, then there's a student who has visited every website. Something like that, yeah. There's a person. There exists a person besides David Belcher who has visited all websites. So it's not using if-then statement for this. Because this one is saying if there's a student that's not David Belcher and David Belcher has visited every website. No. No. I got the parentheses wrong. If there exists a student that is not David Belcher and there exists a student that is not David Belcher, and if David Belcher has visited every website, there exists a student has visited every website. There exists a person beside. There's a person who has visited all this website. There is no person. That is not what it's saying. There is a person who has visited website. This one sounds about right now. There is a person besides David Belcher who has visited websites. So that's this one. Everyone besides David Belcher. That is not what it's saying. There is a person who has not visited a website. That is not exactly what it's saying. There is just saying that there exists somebody who has done it. Not saying that somebody hasn't. Okay. And it's the same domain, X, Y. We have X and Y is not the same. There exists an X. There exists an X and Y where they are not the same, and X has visited every website, and if X visited every website, if and only if Y has visited every website. There are two different people who has visited exactly the same websites. every 2 people. There are 2 different people who have not visited. No. There are no, yeah, so it's this one. Oh, gosh, this is so stupid. What is this music now? I don't like this one. Sure. We're on question 35 out of 57. There's still this one I need to do. Let's not do it till Thursday, so I'll probably do this later this week. And I need this to go along with that. Lectures, I need to read a couple of sections and watch the videos. I need to take notes, lots of notes. I need to go through that. So I want to spend an entire day doing this, probably Tuesday. Yeah, maybe do this tomorrow. This homework assignment tomorrow. I still have another homework assignment for this class too, but that'd be okay. CXY mean student X is enrolled in class Y. Domain is all students in school, and Y is all classes at the school. There exists a student 1 and student 2 where they are not the same. And if the student 1 has taken a class, has taken every class, then student 2 has taken every class. So it's saying that they aren't the same people and they have taken the same classes. They have taken all classes. There exist 2 distinct people enrolled in exactly the same class. There exist 2 second. Yeah, this one's not saying that the first is enrolled in every class 2 has taken, but that is not the true. Every 2 distinct people are enrolled in at least one identical class. No. It's this one here. X1, student 1 and student 2 aren't the same, and what? Is everything else the same? Oh, this is if and only if. Oh, yeah, so that might be the case. If student 1 is taking a class, then student 2 is taking the same classes. So student 2 could have taken even more classes, technically. I don't... Let me see what this one would be, I guess, first, before I just make conclusions. 2 different people, and student 1 is taking a class if and only if student 2 has taken a class. It is a second class version. No. Not every. Okay, so it has to be this one, and this can't be the same as that. So this one probably would have to be. There exists two people. Second, yeah. Okay. Um. If G of X Y means persons X and Y grew up in the same town. Person X and person Y grew up in the same town. Express statement: some students in this class grew up in the same town, exactly the student. The domain of discourse: set of all students in your class. Some students in the class grew up in the same town exactly as the others. At least one student has grew up in the same town as exactly as one other student. There, for every X, there exists a Y. For some X, there exists some Y, where those two are not the same, and I mean, for so far, this one has to be the case. It should be good, yeah? Yeah, I think this is good. Okay. For some student, there exists some other student where they aren't the same, and G of X, Y, where they grew up in the same town, and every for all of Z, for all of towns, and for all towns, I mean everything else is the same, yeah. No, this last part's also a little different. And for all towns, if no, for all students, and for all student Z's, if student X and student Z go in the same town, then student X is equal to student Y, or student X is equal to student Z. I feel like this one can't be true, actually. There's only one person it's true for. X and Y is not the same. It can be, well, student Z can be student Y, but student Z cannot be its own entity. So it has to be an OR state. Yeah, I guess that's to be true, huh? Student X is equal to student Y, which this instantly cannot be true. I feel like this is just false, straight up. Like this one has to be just straight up false. For every... Yeah, I don't know. This just makes so much more sense just using that. CXYZ means person X, Y has chatted with each other in the chat group Z. Every student in the class has chatted. Every student in the class for all of X. Domain is all students in the class for all of X and all of Y. No, all of X has done it for some of Y and some of Z. All of X, some of Y, some of Z. All X, some of Y, some of Z. X, Y is not the same. Chatted with one other student. They aren't the same, and so that's not this one. And at least one. So yeah, it's this one. Fuck. Especially to statements using predicates, quantifiers, logical connectives, and mathematical operators where domain consists of all integers. Difference of two negative integers is not necessarily negative. How different are these? X is less than 0 and Y is less than 0. X less than 0 and Y is less than 0. X less than 0 and Y is less than 0. X less than 0, Y is less than 0. X less than 0, Y is... Okay. So everything except for this one. It's not necessarily negative. So we got two negative numbers. And X less than 0 and Y is less than 0. And X minus Y. Okay, so you're saying that there exists an X and there exists a Y, where those are negatives and the difference is positive. So this one, like just the one I haven't clicked on, right? No, because this is and, or this is an or, we want an and. So could it be this one? Less than 0, and there's Y less than 0, and X minus Y. There exists some where both of these are 0, where both of these are negatives, or that's not right. So maybe it's one of these. I feel like that's not logically intuitive. For every X and every Y, when X is negative and Y is negative, if X is true, then this must be true. No, it's not saying that all X and Y's are negative. If there is not an if there's some X and every Y, I don't know. this one's not true because. But man, I feel like none of these are true. Because x and y has to be negative, which is everything except for this one. You're saying that there is a, not necessarily, so that there exists some x and some y where they're negatives, and the difference is not negative, so it could be positive. So there exists where it's positive. Yeah, that's it. That's this one then. But I want this one to be an and, though. That's my biggest thing. I feel like this should be an and. There exists negative numbers, and those numbers are negative. No. There exists negative numbers, or the difference is positive. If all are negative, then difference is negative. If all are negative, if all y are negative but x is not always negative, if all, my gosh, how do I word this? Because I feel like this one can't be true because of that or. That or just throws everything off. Because this is just saying that this can be negatives or this is positive. That's not true. There exists positive values for those two, which cannot be true. There exist negative values where for all those, there exist negative values and those values, difference of those values are negative or equal to 0, which still can't be true. That's so annoying. So it has to be one of these two, but this doesn't, it doesn't sound right either. Is there something on the Piazza about that too? Because that's so confusing. 39. Q 39. This is so confusing. Because I feel like none of these are true. For sum of x and sum of y, for sum of x and y, there exists a negative number x and y. This can't be true. Like, these ones cannot be true. Because, well, I guess it could be. Because if these are false, then this automatically becomes true. But if these are true, then this has to be true. If this is true, then there's a difference that is negative. But we want a difference that is positive. What the fuck? There exists x and y value where x is positive and y is positive, and the difference between those two. Yeah, no, I'm just gonna keep with this one. It doesn't seem right because of that or, but I can't think of anything else. The absolute value of the sum of integers do not exceed the sum of absolute values. Absolute values of the sum. So for every value, it's true for every value, whatever. Absolute value of x and y added together is not greater than the sum of absolute value of the sum. Okay, so x plus y absolute value is not greater than, so it's less than or equal to, less than or equal to that. So this one, x plus y is less than equal to x absolute, y absolute. Yeah. I hate these multiple parts. Translate, domain, all real numbers, mark all true, there may be more than one. There exists an x where all of y. There exists still x for all of y where x plus y is equal to y. There exists a real number that has the property that adding it to a real number does not change. That would be true. There exists an additive identity for the real numbers. A number that, when added to every number, does not change its value. There exists a value for real numbers, or a number that, when added to every number, for any, no. For all, no. You can find two real numbers. Yeah, I think that's it. Oh my god. Yeah, this is a little louder, isn't it? Okay, cool. For all of x and y, for all of x and y, if x is non-negative and y is negative, then so it's always going to be true. Okay. For any two number, if the first is non-negative, second is negative, the difference is positive. A non-negative. I mean, it's just saying generalized. Yeah, sure. A non-negative minus a negative is positive. That's just, and it's saying that for everything, so yeah, that would be true. For every non-negative number. can find a negative number. I mean, that is technically true. Sure. One can find a non-negative number. And a negative number. So one can find a non-negative number. So that for any positive. I mean, technically all of these are true. They don't translate correctly. That express a mathematical fact. I mean, these are all facts. You can find a non-negative number. You can, because all are true. One can find a non-negative number and a negative number. Oh wait, no, that's not true. One can find negative, so that any positive. That's not true. One can find a non-negative number so that any positive number chosen, no, any negative number is chosen. One can find non-negatives and a negative number for every non-negative number. One can find a negative number for any real two numbers. First negative, non-negative, second is negative, difference is positive. Non-negative minus negative is positive. I think that's it. There exists x and y. There exist two values where there exist two real numbers where one value is non-positive, the other value is two non-positive values, and difference is positive. Difference of two not necessarily non-positive. Yeah, difference of two non-positives is not always. That's not exactly what it's saying, though. Because this could be saying that it's all true. There exists non-positive numbers that first minus second is positive. True. When you have two non-positive numbers, that's not always true. It is true for any. That's not okay. For all real numbers that aren't zero. For all real numbers, what is the truth table for if and only if? If they're both true, if they're both the same value. So if this one's false, this has to be false, and if this is true, this has to be true. For all values, x and y, if this is true, this has to be true. If neither one is zeros, then that's zero. Or if this one is false, if both are zeros, then this has to be zero. Okay. The product of two numbers is non-zero. Product of two numbers non-zero. If and only if both factors are non-zero, true. A necessary and insufficient condition for a product of two numbers being non-zero. Both factors being non-zero. So this one's saying this has to be true for this to be true. For any two real numbers, the following is true. Two numbers are non-zero. Two numbers are non-zero, and and the product is non-zero. I mean, technically true. Two numbers are non-zero, and the product has to be non-zero. The product of two numbers is non-zero if both factors are non-zero. I'm just going to leave it at that. Statement B, x plus y is equal to x minus y. Skew domain for both variables consists of all integers. What is the truth values? There exists a y where every x is true. So let's say we have 0. Would that be true? 0 minus 0 x. Yeah, true. Yeah, that's all we need to do. And then we have the same thing here. There exists an x where all values of y is true. I don't think that's true. I don't think there is an x, x integer, because we can have -1, but it won't be true for all y's. Because we can have 1 plus 1, 1 minus 1, and yeah, that's not going to be true at all. So that has to be that. And I don't know if there's like a way to like really prove that, but I feel like that's the easiest way to say it. Rewrite each of these statements so that the negations appear only within predicates. That is, so that no negation is outside a quantifier or expression involving logical connectives. What? Rewrite them so that negations appear only within predicates. The predicate is the statement. Outside. Okay. So rewrite it so that this only has the negation. There is not a y. That is in parentheses, and we have this here. Can we just distribute that? Not? Because let's say this was not, this would have to turn it into all. So maybe this is an all, and this becomes knotted. All y. I'm thinking maybe that's it. It's either this one. Yeah, this can't be it. The negation is outside a quantifier. It has to be like that, right? There does not exist a y where there's an x, that p is true. That p. There does not exist a y where there's an x where p is true. Where p. There is not a y. So for all y's, right? There is nothing where there's nothing. There exists a value that's everything there exists value where not that. Yeah, I think that's it. Yeah, sure. And if that's the case, that would just get distributed the same way, so that would become some value x, some value y, not p. Some value x, some value not p. Because you can't have a not there. You can't just straight up flip that. That's not how that works. So yeah, it has to be like that. What is this saying? Express the negations of each of these statements. That all negation symbols immediately precedes predicates. So it's basically saying that what? What is it saying? There exists an x, there exists a y, such that if xy is true, then yx is true. Xy is true if and only if yx is true. Both those have to be true, or both those have to be false. Express the negations of each symbol. So we have to take the negation of both of these, right? How do you take the negation of if and only if? I don't know. No. No, if you can. Both of them have to be true. Yeah, this is so confusing now. I could just say the exact same thing. Sure, why not? Flip it. That's already flipped. Yay. I don't know. Maybe. Sure. Express the negations of these using quantifiers. Let x of y, let L of x and y represent x likes the subject, y. So x likes y, where x is all students, y is all subjects. Use to negate this. every student in this class likes mathematics. So we say AX EY, and X would be everyone, Y specifically math. For all of X, L, X, Y, mathematics, negation of that would be, you flip that, you switch that, sure. Expression that means that some students in the class does not like mathematics. Yeah? I feel like that's right. That's definitely not here. It's not every, not all, not all. That's true. So it's likes, not likes. So yeah, okay, that's it. SX represent person seen object. Somebody hasn't seen object. Y, X is all students. Y is all objects. Negation. There is a student, so EX not S X computer. So EX not S. EX not S X computer. So this one here. Flip that. Take the not out of it. Yeah. Yeah, this one's a little bit easier, honestly. So we have X has taken math. X taken math C. X is all students in a class. C is all math classes. Negation. There is a student. So EX EX has taken every mathematics. EX TXC. Or I guess EXA. Yeah. AX exists student take when all courses. Student X has taken all courses. Is there another one that looks similar to that? No. So this has to be it. Because it's not all students. They're just students, yeah. Was taken every not okay, yeah. Negation, we would flip that to be A, flip that to be E, so AX, EC, not T. Yeah, that's exactly what we have there. Okay. Room Z, building Y. For Q, it is student X, room C. EX, EZ, EX, EZ, every AZ, AY. EX, EZ, AY. EX, AY, EZ. EX, AY, EZ, EX, AY, EZ. So it's one of these three. Um, Z is in building Y, and student has been in Z. So it's an and statement. So it's not this one, that's an or, so it has to be one of these two. It's not knotted, so it has to be this one. Sure, why not? Okay, last group ones. Determine the truth value of the statement. All x, there exists y such that the product is 1. So, yeah. So, I mean, as long as it's real numbers. If it's integers, then no. If the domain consists of... Yes. True. Integers, false. Positive real numbers, true. Yeah, if it's only using positive numbers, that doesn't matter, yeah. Let me check here non-zero, so as long as they're not 0. Yeah. Because you can have 33, and as long as you can use 1 over 33, it's 1. You have to use the inverse for the y to actually get that to be true, to be 1. And positive numbers is the same premise. All positive numbers. So that should be it. And let's see how much I got wrong. Not too bad, really. So what, I got these two wrong here. They're existent. Yeah, and that one is... Yeah, that one's obvious. This one was a bit more different. There is a student at your school. Yeah, that's just straight up wrong too. Okay, me rushing that. Good. This one was just straight up wrong. This one was the one I just guessed because I couldn't figure it out. That one's not right. So for this one, express. So anything that's not no. Everything that's not 1. Because P has to be true. Yeah. Okay, sure. I only got partial credit for this one because I got this domain wrong. What was the answer? Consists of all people. Everyone in your class has a cellular phone. There exist some people, if they are in your class, then they have a phone. I guess that's true, huh? For everyone. If they exist in your class, that's not true. Or that can be true for that. Because if they aren't in the class, that's automatically true. But if they are in the class, P has to be true. Yeah, that's exactly what it's saying down here. one's good, that one's good, that one's wrong. And I was just confused with what this was asking exactly. I figured it was one of those two, so that's fine. Yeah, I guess that makes sense. Just some if it's tautology. And this one, I think I just took the opposite or took the same one. I don't know. Oh, this one. What is this one? The original statement. Oh, okay, yeah. I got confused with what it was asking for an indication, but it's just saying not all Swedish movies are serious. So some are not serious. So yeah, that would have been right. Yeah. Oh well. That's right. That was right. That was right. 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 I think I'm gonna get most of these other ones right. Maybe not all of them, but because I did get a majority of all these correct. Oops, there was one. I got a little confused with this one too, didn't I? What isn't necessarily? Not necessarily negative. This explanation is to assert that a certain universal condition is not true. Okay. So necessarily means that one of the universal conditions can't be true. Okay, that makes sense then. And that one, yeah, it was easy. This one I got partial credit. This one was not true. You can find two numbers. I mean, technically, I think that's true, but you can find two real numbers with the sum of the first and second number is the second number. Yeah, I think technically that would be true, but I guess in this context, yeah, no, shouldn't think of it like that. It's same thing with this one. Because my thought was technically that's true, but clearly technicality doesn't really matter in specific applications like this. For this one, I would have assumed that would be true actually, though. For any two real numbers, first is non-negative, second is negative. Oh, that's an and, that's not if then. One can find for every non-negative. That's not exactly what it's saying. That's saying ax ey, which isn't technically true. Sure, fine. One can find is saying ex instantly and ey, which is technically true, but it's not what they're looking for. Sure. And this one, difference of two non-positive numbers, not necessarily non-positive. Two non-positives and difference not positive is positive. See, that's technically not true in this, because they could be, but not necessarily. Yeah, I guess that's true. Yeah, I guess. Sure, it's not necessarily true, but it could be. I guess that's what I was thinking of. This one, yeah, I should have went back and looked at this one. If we just take the not, the negation of that, we have no. Um, that is switched to an A. That one stays. That one's okay. That one's not the answer. The answer is we flip both of them and take that because we take the negation of all of it. I guess, even though that's not in parentheses. Okay, sure. And the same thing here. We flip that and we flip that. We'll take the not of that. Okay. Same thing here. Flip that and flip that. This one was just a guess. I guess I should have known to flip both of those at least still. So I would have gotten at least one of these two. Distribute that not, have that not, that, just put that there. And then when we distribute that, only the second one's not. Interesting. Good to know that though. I'm gonna actually write that one down, because that one is pretty necessary. Not Q, Q is equivalent to P, not Q. Okay. Good to know, good to know. And this is where I realize, oh, let me actually just flip them all. And then same thing there. Blah, blah, blah. Okay. Okay. So I'll work on this tomorrow. I'll do this maybe Tuesday along with the reading. If I have time tomorrow, I'll do it. And my other written assignment for this previous class that I was just doing tomorrow, probably. That should be good, yeah. Yeah, that'll be fine. Get started on that tomorrow, maybe Wednesday even. But yeah, hopefully I can. My main goal is to finish this one tomorrow. Finish this Tuesday, and then the last one on Wednesday.